Welcome to the unit on the binomial expansion, Pascal's triangle. The objectives for this session are to use Pascal's triangle to identify binomial coefficients and use binomial coefficients to expand simple binomial expressions. It is possible to expand expressions such as x plus 2y all cubed using Pascal's triangle. Pascal's triangle is formed by adding adjacent pairs of numbers to find the numbers on the next row. So let's illustrate how this is done and see how Pascal's triangle is constructed. It begins with a 1 and a 1 on the next row down, here and here. Next we add the two 1s and place the answer in the row below in between the 1s, which is 2. Again, we transfer a 1 to the row below as shown, and the other 1 as shown. And similarly in the next row down, and similarly here as well. Next we add 1 and 2 to give us 3, and we position that in the next row down as shown. Similarly for 2 plus 1, again we transfer the 1 down and the 1 down here. We add the 1 and the 3 as shown and position the 4 in the next row down. 3 plus 3, 3 plus 1, 1 goes in the next row down and the other one here. 1 plus 4 is 5. 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is 5. Then we repeat. 1 goes here, 1 goes here, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, and 5 plus 1 is 6. And so on. These are the first 7 rows of Pascal's triangle. Let's consider the first 5 rows of Pascal's triangle. And then let's see how this links with the expansion for a plus b all raised to the power n, where n equals 0, 1, 2, 3, 4, and so on. What happens when we expand the expression a plus b all raised to the power 2? This gives us 1a squared plus 2ab plus 1b squared. But how does this link with Pascal's triangle? Notice the third row. We have the values 1, 2 and 1. And now look at the coefficients. You can hopefully see how these two now link up. What about the other rows? a plus b all raised to the power 0 equals 1. And looking at the first row, we can see that there is just one value there, and that's 1. What happens if we expand the expression a plus b all raised to the power 1? This gives us 1a plus 1b. And looking at the second row, we see that there are two values there, 1 and 1. And you can see, hopefully, that these correspond to 1a plus 1b. And similarly, for a plus b all raised to the power 3, if we look in the fourth row, we have the values 1, 3, 3, and 1. And again, these correspond to the coefficients 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. And likewise for a plus b all raised to the power 4, where the values in Pascal's triangle 1, 4, 6, 4 and 1 all correspond to the coefficients in the expansion for a plus b all raised to the power 4, as you can see. So the first row gives the coefficients in the expansion of a plus b all raised to the power 0. The second row gives the coefficients in the expansion of a plus b all raised to the power 1. The third row gives the coefficients in the expansion of a plus b all raised to the power 2. And similarly, the fourth row corresponds with the expansion of a plus b all raised to the power 3. And the fifth row corresponds to the expansion of a plus b all raised to the power 4. And so on. So the n plus 1th row gives coefficients in the expansion of a plus b all raised to the power n. Now let's try an example. Use Pascal's triangle to find expansions of x plus 2y all raised to the power 3 and 2x minus 5 all raised to the power 4. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a first. We're looking at the expansion of x plus 2y all raised to the power 3. So we're going to concentrate on the fourth row. If we expand a plus b all raised to the power 3, we obtain the values you can see on your screen in the fourth row. However, we're required to expand x plus 2y all raised to the power 3. So in our expansion for a plus b all raised to the power 3, we need to substitute a for x and b for 2y. And doing so gives us the expansion 1x cubed plus 3x squared times 2y plus 3x times 2y all squared plus 2y all cubed. And tidying this up gives us x cubed plus 6x squared y plus 12xy squared plus 8y cubed. And now for exercise 1b. We need to expand the expression 2x minus 5 all raised to the power 4. The expansion for a plus b all raised to the power 4 has been highlighted on your screen in Pascal's triangle. Notice the coefficients that are relevant to us are 1, 4, 6, 4 and 1. So this time, let's substitute a for 2x and b for minus 5 to give us a equal to 2x substituted as shown and b equal to minus 5 substituted as shown. And then tidying up gives us 16x to the 4 minus 160x cubed plus 600x squared minus 1000x plus 625. Let's have a go at another example. In the expansion of 4 minus cx all raised to the power 3, the coefficient of x squared is 300. Find the possible values of c. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve example 2. Again, let's consider the expansion for a plus b all raised to the power n, for n equals 0, 1, 2, 3, 4. Again, you have Pascal's triangle in the format for a plus b raised to the power n for the first 5 rows. We are particularly interested in the fourth row, so a plus b all raised to the power 3 is equal to 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. And so the relevant coefficients for 4 minus cx all raised to the power 3 are 1, 3, 3 and 1. The term in x squared which we are interested in with regards to our question is 3 times 4 times minus cx all raised to the power 2. Notice that if we expand a plus b all raised to the power 3, the x squared term is 3ab squared, and we've just simply substituted a equal to 3 and b equal to minus cx. And so this tidies to 12c squared x squared. And therefore 12c squared equals 300 as per our question. And rearranging and tidying up a little bit gives us c squared equals 25. And of course this implies that c equals plus or minus 5. This brings us to the end of this session. If you have understood its contents, you should be able to use Pascal's triangle to identify binomial coefficients and use the binomial coefficients to expand simple binomial expressions. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.